my dear students, how are you? I hope you are all doing fine. Today we are going to continue our lesson 1 about electricity, okay, in unit 10. In our previous session we have studied the static electricity, and we have said that static electricity means the building up of charges on a body or an object, the static electricity. But today we have another kind of electricity, which about moving of electrons. Do you remember the electrons? Yes, these negatively charged particles, moving of electrons in a wire, in a copper wire. So here is a copper wire, this yellow one, and those blue dots refer to the electrons. So moving of electrons easily in this copper wire mean electric current. Okay, so again, when the electrons are moving easily through this copper wire, this moving is called, the moving of the electrons is called electric current. So when the electric charges have a path to follow, this flow of charges is called electric current. So again, the electric current means the flow of electric charges or the negative charges, which are the electrons. So again, the electric current means the flow of negative charges or the flow of electrons. So what about this insulator, this green one? Do you remember before when we studied the rubber, which is an insulator of heat and electricity? We have said that rubber is an insulator for both heat and electricity. Yes, and we used it for covering the electric wires in order not to be shocked by electricity. So this insulator on the wire shown above is a material that resists the flow of electrons in order not to the electrons go out of the wire, harming us, causing us by the electric shock or causing an electric fire. So it means a safety mean. It's a safety mean for us, and also it resists the flow of electrons. So this insulator, it means that, or its job is like that. So what about the sources of electric current? I mean, the electric current is coming from where? From where can we get the electric current? Actually, we have many sources. The most main sources are batteries. Do you remember the batteries? Yes. The chemical reactions take place in the battery changes into electrical energy, as we have said before in the energy changes. So batteries is a source of electric current, and also energy stations or energy generating station. This electricity coming from it, electricity generating station or energy generating stations. These stations produce electricity or electric current, but for houses, for schools, for hospitals, for factories, for big places, not like batteries. Batteries, we can use batteries in remote control sets, in watches, in toys, something like that, but not that much. Okay, so again, chemical reactions in batteries produces electric current, and also the electricity generation station produce electric current. So moving electric charges are more useful than static electricity. I mean, this kind of electricity is more useful in our daily life than the static electricity. We have studied in our previous session the static electricity is not that useful, it's not that important, but moving the electric charges or this kind of electricity, I mean the electric current, is more useful than static electricity. Why? Because electrons moving through the wire forming electric current. As we have said since a while, electrons moving through a wire forming something called electric current, and you can use this electric current to do many kind of work. Like what? Like cooking food by the electric stove, like lighting home, lighting houses by using the electric lamps, like producing sound by using the electric bell, by using the radio, by using the television. You can produce sound by the electricity. So the electric current, it's useful to do many kind of work in our daily life. That's why it's more useful than static electricity. So electric currents, by the way, as we have said now, for homes, schools, and businesses like hospitals, like schools, like factories, come from energy stations. From energy stations or from electricity generation stations, not from batteries. We cannot switch on lights or switch in television, washing machine, and switch on the devices, electric devices in the schools, in the hospitals, in factories by batteries. Of course not, impossible. So the electricity coming to the homes, schools, and businesses or offices, offices, factories, companies, always from energy stations, not from batteries. And the energy stations, these energy stations change the chemical energy, the nuclear energy, or even mechanical energy, those kind of energy, into electrical energy. Again, these energy stations we have mentioned before change chemical, nuclear, or mechanical energy into electrical energy, and we can use it in our daily life. And this electrical energy coming from the energy stations, the wires carry it. The electric wires in our electrical equipment carry it from the generation station to every outlet in your home, or in your school, or in the hospital, in your factory, in the house, in the office, every place. So again, those wires, the electric wires, carry the electrical energy coming from the generation station or from the energy station to every outlet in your home or in your place. Okay, so this is about the electric current and how it is more useful than static electricity that we have studied in our previous session. Now let's do an exercise together, okay? Then playing a game. So about the exercise, let's complete those sentences or fill in the blank places. For example, here it said the outline below is a summary of the lesson, so complete the outline. We are gonna complete these places to make a quick revision or a quick summary for this lesson. For example, let's start. Number 1, electric charges. Each of these types of particles that make up atoms has a different charge. Do you remember the atom? Again, let's remember together. The atom consists of 3 different particles, which are protons, what else? Neutrons, yes, and electrons. So let's complete the sentences. Protons have a positive charge. What else? Electrons have what? Negative charge, yes. And the neutrons, do you remember? The neutrons have no charge, yes, have no charge or neutral. So electrons, number 2, electrons have a negative charge while neutrons have no charge. Another question. Atoms can gain or lose electrons. Yes. So for example, in the static electricity, the definition is it is the buildup of electric charge on an object, as we have said before. Yes, we know that. Objects with charges interact with each other. Like what? Like charges repel. Like charges repel. I mean positive and positive, or negative plus negative, negative and negative. So what about opposite charges? Do you remember? If the like or similar charges repel, so the opposite charges attract. Number 3, electrostatic discharge. Do you remember the electrostatic discharge? Yes, it happens sometimes in a small or a short range in our houses and in a big range in lightning. Yes. So the definition of the electrostatic charge, it is the jumping of electrons from an object to another. As we have said before, it is the jumping of electrons from an object to another, from the object of negative charge to the object of positive one. So for example, getting choked after walking across a rug. You know the rug, like a carpet. Sometimes you are moving on a carpet, sometimes you get choked. Yes. This is called electrostatic discharge because the electrons move from the object to another. So another example, we have to know another example like what we have said since a while. It is, yes, lightning. It occurs in a big scale, on a large scale, as in lightning. And here is the last question, which is electric current. We have defined it since a while. What's meant by electric current? Electric current is the flow of electrons. Yes, the flow of electrons, or the flow of electric charges or negative electric charges. The sources of electric current, we have said that there are two sources, generating stations, and first one was batteries. Yes. So this is a very good summary for the lesson. I hope you are going to study it well. Okay, and now let's play a game together. Yes, by the way, this word play in page 493 in your book. You can see it, you can check it. Let's play it together, and you can play it another time again alone. Fill in the blank in each sentence, then find the word in the blanks in the word search below. We are gonna fill in these blanks, okay, the blank in each sentence from these words, and every word we are gonna make, you have to cancel it from here, so we can make the crossword, or we can make the secret word at the end to solve this riddle. Okay, are you ready? Let's start. Number 1. Two positive charges space each other. Two positive charges space each other. Two positive charge making what? Repel or attract? Like, they are like charges, similar. So yes, repel each other. So where is repel here? Let's search where is repel. By the way, you can search it by the word may be starting from the left to the right, or from right to the left, or from up to down, or from down to up, because it's a game. Okay, so yes, here is repel, R-E-P-E-L. So let's cancel it. Number 2, a positive charge and a negative charge. This time they are opposite charges. So they what each other? Repel or yes, attract each other. So where is attract? Let's search together. Yes, here is attract, A-T-T-R-A-C-T. So we are gonna cancel it. Okay, so by this way it will be the game. So let's continue. The building up of electric charge on an object is, yes, static electricity. So where is static here? Static. Yes, here is static, but here in this time it starts from the right to left. S-T-A-T-I-C, static electricity. So we cancelled it. Number 4, the flow of electric charges along a path. The flow of electric charges along a path is called electric what? Electric current. We have studied it now. Electric current. So where is current? C-U-R-R-E-N-T. So it is current. E, letter E, the fifth one. A proton has what? Which charge? A proton has positive. Yes, where is positive? Let's search together. Positive, yes, P-O-S-I-T-I-V-E. Positive. So it will be this one. A neutron, what about a neutron? Is what? Because it has no charge. So since a neutron has no charge, the neutron is neutral. Yes, neutral. N-E-U-T-R-A-L. Neutral. So we are gonna cancel it. Neutral. And electron has which charge? Electron. Yes, negative. N-E-G-A-T-I-V-E. Negative. Let's cancel it. And the last one, electricity is produced at a generating station. Yes, station. S-T-A-T-I-O-N. Let's cancel it. So now the remaining letters, we have to arrange them to get or to solve this riddle. So here it said, find the letters you didn't circle or you didn't cancel in the word search. Write them in order from left to right in the blanks below to solve the riddle. From left to right. We are gonna arrange them as they are. Okay, so the riddle says, what do you call a very scary electrostatic discharge? Again, what do you call a very scary electrostatic discharge? So now very scary means very frightening. Let's now arrange the letters F R I G H T E N I N G. So it will be frightening. Yes, frightening means scary, scary, frightening. So let's continue. L I G H T N I N G. Lightning, lightning. So the very scary electrostatic discharge means frightening lightning, frightening lightning. Okay, so I hope you have enjoyed the game and study well lesson 1. Okay, and we are going to make a revision on our next meeting. See you, my dear students, and bye bye.